will be recorded. So if you don't want to be filmed, it might just be a good idea to turn your video off. And if you could possibly mute your mic, that would be brilliant. If you have any questions, there's a little chat box. So if you want to type in any questions that come up throughout it, or at the end you have a question that hasn't been answered, type it into the chat box and we'll answer those questions as much as possible at the end. That would be brilliant. Okay. So today we're here to look at worked examples with cognitive overload. So I'm Sarah. I am a 2017 Teach First ambassador. I trained in East Midlands and moved to London. And during this, I found a love for the research and finding out how I can help students to learn more. And I never had enjoyed research as much until I did this. So weirdly, this is how I found I liked it. And what we're going to discuss today is primarily based on what I have learned throughout my career and how I've implemented the research. So it's what I found works for me. It might work slightly differently in your context, but you can still apply the same ideas. I'd just like you to quickly, 10 seconds, think to yourself, what is learning? What would you describe learning as? 5 seconds left. Okay, so I don't know what you've all come up with, but whenever people usually ask this question, they normally say learning is like learning a new skill, able to answer questions on this topic. But when you think about it in the terms of definitions, it's actually defined as a change in the long-term memory. And without this change happening in the long-term memory, nothing's been learned. So if this change doesn't happen in the long-term memory, researchers say that nothing has been learned. So how do we make that change in the long-term memory happen? Well, we need to start off with the working memory. The working memory holds 3 to 5 things, and it's still in debate really of how much they actually hold. And they think that it's about 3 to 5 is what we've focused on at the moment. Now, the working memory takes in everything that's going on around us, and that is like the processing place of the brain. So it could be like, oh, someone's talking to me in the lesson. That could be the first part. It's the lesson itself. For some students, it's their timetables. It's what information is being presented as well that is being taken in, and also like what happened at break time. That could be in their minds the whole time. Now, as this stuff's being coming in, it's processed and encoded into the long-term memory. And when it enters the long-term memory, it forms schemas, which produces that learning. So that produces the change in the long-term memory, which makes the learning happen. And that's what we can define learning as happened. Now, at the moment, we seem to think that the long-term memory is infinite. We haven't been able to find capacity for the long-term memory yet. Now, as you do this encoding from the working memory to the long-term memory, it actually uses up space in the working memory. So we need to use one of those 3 to 5 things as the encoding aspect. Now, if we want to retrieve things, so recall something from the long-term memory, it doesn't take up any space in the working memory, which is why we want it in that long-term memory, because then you can just recall it and it doesn't use any, so we've still got that space for processing in the working memory. If we take timetables, for example, if I said to you as a maths teacher, what's 6 times 3, you'd instantly say, oh, 18. And that's because it's a retrieval, you just know it. It's in your long-term memory, you can recall it without having to think about it. But for some students, they still in their working memory. So they have to go, okay, so I've got 6, 12, 18, and then they'll get to the answer, and that is taking up that space in the working memory. So it's something that we really have to be aware of when we're doing problems or giving them problems to do. Now, if this working memory becomes overloaded and there's too many things going into the working memory, the encoding becomes hindered. And as that coding becomes hindered, there's less space in the working memory for the encoding to happen, because there's so much going at the working memory from outside sources. Cognitive overload occurs. And this prevents us from being able to learn anything, because we can't encode anything, we can't make the change in the long-term memory, which means that the learning can't happen. Now, everybody will have felt cognitive overload at some point, whether it's you've got writer's block, or you're trying to do 10 things at once and you don't know where to start. Or if you've got like 6 people talking to you at once and you can't listen to everybody and you just sort of zone out a bit. That's type of cognitive overload. And the cognitive overload at any time hinders the learning process. It hinders what you're trying to learn. So this is why we need to be able to prevent it. Now, if this was to occur in the classroom, and we'll send this out so you've got more time to look at it, we've got the characteristics that I've seen it happen and that researchers have seen it happen and how this could occur in your classroom. Now, I'll send that out and give you more time to look at what to look out for when you're looking for cognitive overload. But what we want to focus on today is how can we change this so that we can reduce the cognitive overload, enable the encoding to happen, and reduce that stress, that pressure on the working memory. So how can I do that? Well, there's certain things that we can control in the classroom. In the classroom, we can control behaviours, we can control distractions, we can control who's talking to who, we can control if someone's throwing something across the classroom, or we can try anyway. We can control what type of activities we're giving students to complete. We can direct their attention to certain parts of the lesson, and how we present the lesson is within our control. Now, we're going to look at this in two parts, classroom and online, because online teaching has become a big thing with the recent COVID. Now, when we're looking at online, the only three things that we can primarily look at is activities we're giving students, attention of where we're asking them to put their attention, and how information is being presented, because they're not in our classroom for us to be able to control that behaviour. So what we're going to focus on are attention and how information is being presented. Now, this method that I'm going to show you today is a method that I found works to reduce cognitive overload in all my classes, and as it enables space in the working memory for encoding. So I can do that by controlling the way that things are presented and by purposefully directing students' attention to exactly where I want them to look at. So you saw these questions at the beginning, but now in a slightly different context. Instead of being asked to do them, how would you teach these problems? Well, I'm going to show you a way to do this. Now, when we're teaching these problems, and the ways that I'm going to show you now can also be used for harder, more complex problems, like problem solving and wordy problems as well. But I've used these three examples as they're really clear to show the difference between them. So then I go around and I have a look at what people are teaching. I see a lot of this where people put the question on the board and then they put their worked answers on the board and then they'll talk through it step by step what they're doing. Now this is great because we've got the worked example and not just the answer, and the teacher is talking through it. But this actually causes a lot of cognitive overload because you've got the question, you've got the answer, everything is there. There is far too much there for the students to take in one go. They do not know where to put their attention. As the teacher is talking, they don't know whether to look at x equals 0.11 or 10x equals 1.11. And as this happens, they get overwhelmed by the amount of information they're expected to take in. So it takes up all the space in their working memory, and it hinders their encoding because all the space is being taken up, like, oh, Miss is talking, oh, I've got to look at this part of the question, oh, wait, no, where is she? They don't really know where to look. So how can we make this better? Well, here we are. So what we can do is we can change it so that we have the question, and this is exactly the same question, but as we talk through each part of the question, we gradually reveal each step. I'm not going to talk you through it because you're maths teachers and you know how to do that. But I reveal each step as I talk through it. Now, if I was to do this in the classroom, I would do this through live modelling it, put silent teach where appropriate, where I live model it, pausing at each step and then explaining it. But online, I would reveal it the same way as I just have done to you. Now, how does this help? Well, it directs students' attention to the exact step that you are talking about. It removes the distractions of where am I meant to look? Am I meant to be looking at the top or the bottom? Because you've directed them at that exact place. And this leaves a lot more space in the working memory for that encoding, which is what the aim of the game is, to encode the information to learn it. Now we can make this even better by doing this, and Mr. Barton loves this method if you've read his books. So you're going to split your page in half, and when you do this, you're going to have two questions on the board. The first one, we're going to do exactly the same way as we've explained when we gradually reveal each part, explaining each step as we go along. If I was in the classroom again, I would have live modelled that. And then I would put a question for the students to complete on the other side. Now, what I'm doing here is I've got the question, which is exactly the same. It doesn't change. It's not got 2 decimals recurring, 1 decimal is still recurring. It's just changed the numbers. And then once they've had a go at this, on their mini whiteboards is what I'd ask them to do in class, because it's risk-free. It means that they don't have to worry about making mistakes. I'd then go through each step. If I was in class, in the classroom, I'd ask a student to explain each step as we go through. However, if I was online, I would just explain each step and reveal each step as I go along, the same way as I did for the first one. But how does this help? Well, this helps even more than the previous one, because it further reduces that burden on the working memory, because students aren't having to look back to their book like, oh, what did you do here? Oh, there's the question, what am I doing? They've got it on the board. Miss did x equals 0.11. I need to do x equals 0.44. What did Miss do? Times by 10. What do I do? Times by 10. It gives them that direct focus of attention. And again, if we're sparing the space in the working memory, it gives more space for encoding into the long-term memory. So learning is happening much more successfully. Now, worked examples are basically a step-by-step way of how to do a question. And it's a structured way, and they are great ways for doing questions that are quite complex as well. How would you use these in the classroom though? Well, there's 2 ways that you can use this in the classroom, and I'm going to show you both ways and then explain which ones are better for the learning and reducing the cognitive overload. So the first method we've got is where we have the first worked example, the same way we just spoke about it, where you have the question, you talk through each step as you reveal it, then the students have a go, and then you talk through each step as you reveal it. Then we do the same with worked example 2. So this would be 2 decimals recurring now. So worked example is 1 decimal recurring. So this one's now 2 decimals recurring. And we talk through each step, revealing it as we go along or live modelling it as you go along. And then you ask the students to have a go. And then you reveal the answer the same way as we've always been doing. We talk it through, or you reveal it step by step. I've just made them all reveal at once just to save time now. And then I do worked example 3. So I've got 3 decimals recurring now. Step by step, explaining each step as I went through it, revealing it, then ask them to have a go. So now they've had a go at 3 different worked examples. So they've done an example with the teacher, and then they've had a go at a question within each of those worked examples. So then I'd give them like mixed examples or practice questions for this. Now, this is a method that I used to use a lot, and I found that actually this was creating a few problems. But why is this creating a few problems? As you can see, question number 4 is 3 decimals recurring. So that refers to worked example 3. Question number 6 refers to 2 decimals recurring. So they're crossing over. The students are having to identify which skill they're using where. And this actually increases the cognitive overload because students have not had a chance to practice a skill, encode the skill into the long-term memory before they're asked to identify it. I understand that we want students to identify which worked example is in which question, but they need to be able to do the skill first. So I used to spend a lot of time on the worked examples like I just showed you, and then it would come to these mixed problems and students would struggle with it and I'd be like, why? We've just done it. You were doing great. Like, what happened? And I'd end up going around explaining it to students or different questions again. And I was like, right, something's going wrong here. This isn't the ideal way of teaching. So I did a bit of research and I found that there was actually a different way of doing this, which reduces the cognitive load even more. And this method was through breaking it down slightly further and inserting a practice problem after each worked example. So we did the worked example exactly the same way, revealing each one step by step. And then the students would have a go, revealing each one step by step. But instead of moving straight on to worked example 2, I'd put this on the board. And this is a chance for the students to practice the questions that they've just learned. So I've only got 1 decimal recurring because worked example 1 was 1 decimal recurring. I've got 4 questions and then 1 challenge question. I'd usually put an exam question on my challenge. Now, what this does is it enables students to look at their work and be like, right, only looking at this one skill, I'm going to encode that into my long-term memory because there's nothing else to distract them to take up that space in the working memory. Then I'd put answers on the board if I was doing this online. But if I was live modeling this, I would ask the students to explain the questions to me. If I was in the classroom, I'd probably ask them to do it on mini whiteboards as well to reduce that risk, that fear of making a mistake. And then I'd repeat this process for worked example 2 and worked example 3. So I'd have my worked example 2, I'd step by step it, then the students have a go, step by step again. And then insert these practice problems. 2 decimals recurring now, nothing else. No 1 decimal recurring, just 2 decimals recurring, because that's the only thing that we just looked at. And I'd have them to have a go. I'd do the same thing again. I'd either explain the answers if I was in school, write them down, do them, or I'd reveal them gradually if I was online. Worked example 3, I'd do the same thing again, this time with 3 decimals recurring. So I do it where I do my example step by step, students have a go, then they reveal it step by step. And then I do again my 4 problems and 1 challenge problem. Now these practice problems again are only on 3 decimal recurring. There's no 2 decimals recurring, there's no 1 decimal recurring. This is purely because worked example 3 only looked at 3 decimal recurring. And then I do my worked exam answers as well. At this stage, the students have had examples, practice problems on each of the different 3 skills that we're looking at. So then I'd give them these mixed practice exam questions. Now, how does this help? How is this better than the previous one? Well, it allows students to take their 1 decimal recurring and encode that skill before they're asked to move on to the next one. It takes 2 decimals recurring, and the students are able to encode that as well. And the same with 3 decimal recurring, because they've had that practice part as well. It's step by step, so it's really, really small parts, which leaves more space in the working memory for the encoding to the long-term memory. And additionally, it doesn't help with like the encoding or the cognitive overload, but it increases students' confidence in those problems. So what they're doing is, first of all, they're practicing the skill, and then when they come to these mixed questions, they're identifying which skill they're going to be using, because they're recalling the information from their long-term memory, which doesn't take up any space in the working memory, because they've previously encoded it in the practice problems. Now, obviously, if we look at this, it's a lot longer. It looks a lot longer anyway than the first example I showed you. However, I found that this actually doesn't take up any more time than the previous styles of questions, because students would sit there on the mixed example questions, previous one that I showed you, and be like, oh, I'm not sure what I'm doing, I can't quite do it. Whereas with this version, the students have had that practice time. They are confident with those questions. They are encoded into the long-term memory, and they have that stronger schema connection. And then they can apply it to the mixed questions, which I found actually takes less time because they have that opportunity to recall it, so they're not taking up the space in the working memory. So it increases their confidence as well, so greater learning happens with this structure. So, So a worked example problem pair is very, very effective, not just with these types of questions where it's systematic, but with problem solving as well. It can work with any type of question. And I love using these in every lesson. And I would personally choose the worked example problems every time, no matter what subject or the level of students I'm teaching. But why do we use it? Just to summarize. We use this because it enables us to focus the students' attention directly at where we want them to look at. It removes the distractions or reduces them if we're not in the classroom. And as a result, because those distractions and that are reduced and the focus is targeted, it reduces the cognitive overload, because the working memory is not having to do as many things. It's not having to take in as many things to take over that 3 to 5 things that the working memory can take. So it leaves more space in the working memory for encoding into the long-term memory, which, as we learned at the beginning, means that more learning is taking place. So the benefits of this is that it breaks down the learning. It enables students to have a really strong understanding of each type of question, sub-question, before we put them into where they have to identify the skill. For lower attaining students, I personally would, depending on the topic, obviously, I'd make the practice questions maybe a bit more than just those 5, depending on their attainment. And another little positive is that it reduces the panic when they're asked to have a go. So I've got these year 10 students, and the girls used to panic loads when I used to say, oh, off you go, have a go. They used to just see fear in their eyes every time. But using this method of example pairs, these students have done it on their whiteboards or their books, wherever they felt like it. And then I say, okay, have a go at these next questions. They're like, yeah, miss, I can do this. And that is such a nice feeling to know that they're confident to do it and they've got rid of that panic. But while they're able to learn a lot more because they've got that greater space in the working memory to encode it. So thank you very much for attending today. I think I'm just about on time. Bethan, have we got any questions?
We have one from Alison saying, how does it ensure that there is understanding rather than it just copying a procedure?
So it depends how you're going to present it. So procedure, we need them to know how to do the step-by-step before we can ask them to recall the skill. And I think that in maths, it's a lot about practice. So they've got to be able to understand what they're doing. And that's why you take questions. That's why you ask the students in the, sorry, bear with. When you're in this stage here, when it's have a go, I would always ask them to explain to me, how have I done this step? What have I done next? As I'm revealing it, as I'm writing it. So that is what I find really helps them know the understanding. And I know you can't do that to everybody, but especially in these work practice problems, you can ask a lot more students to explain the answers, to explain how they got their answers, the step-by-step guide, than if you're just doing 3 examples, throw them into some practice problems. Does that answer the question?
I mean, I think so. I don't know if Alison agrees. Please do keep posting your questions, by the way, and I'll read them out as we go. I asked a question initially saying, is this more aimed towards your lower prioritators or middle prioritators? Because it seems like it's quite a long process for your higher prioritators who perhaps could get it quicker, but I'm not sure if that's...
I personally would use it for every class. I use it for my top set year 10s that I've got at the moment, and I use it for my my nurture groups as well. I just extend the type of questions that they have, the more practice questions they have. I mean, it looks longer, but actually because they've got that understanding, because they've encoded it and they've got the learning, the retrieval is much quicker for the practice problems, and they actually get more exposure to lots of different types of exam questions that they wouldn't have had before, I've found. And also they like to be able to know that they can do the skill, especially my top year 10s, before they can move on. So I find that it actually works at every attainment, and it doesn't add time to your lessons at all, having done both of them.
Thank you. We've got another question from Saranian saying, you say asking how they got it. Does that cover the why though? For example, why do we multiply by powers of 10?
I'd ask both if I was doing it. That was just one that came to mind at the moment, but I'd ask both. Any questions that you'd normally ask when you're explaining them, they can fit into this model.
And Sam's asked, what are your thoughts on learning versus performance?
I think that's a question for a different day, because I don't think that has overly much to, I think that's more about recall rather than how we're reducing cognitive overload, because yeah, I think, sorry Sam. I think that's a different interesting topic.
And are there any other questions from anybody, or any follow-up questions from what Sarah's just gone through? Would you go through this same process at a later date in a follow-up lesson?
Depends on what set and what I was teaching, really. So if they've already had this lesson on recurring decimals, if they needed it again, I would go through the same process. If I felt like they just needed some more practice questions, or they just had a missing understanding of, I don't know, the third worked example, I just target that one. So I think that depends on your class personally. I would use this method if I was doing feedback as well. So for each group that I put them into, give them the 4 questions after they've had their worked examples as well.
Hugo has accidentally messaged me privately, but he says, are there any topics which don't work with example problem pairs?
I personally haven't found any yet. The only thing I would say is occasionally, and I hate doing this, occasionally they're too big to fit on a screen like this for the students at the back to be able to see. The wordy questions, the ones that need lots of working out. That's the only slight issue that I'd say, and at that point I'd unfortunately have to do it on 2 slides, but I'd still follow the same method, and I haven't found any topics that don't work with this method.
I think I'm going to reduce it for 2 more questions because we're getting quite a lot now. One from Jonathan saying, do you think you should show every eventuality or every type of question in your example problem pairs?
It depends what you're going to test in the mixed questions, really. So whatever type of questions I think that you're going to do in the mixed practice, apart from your challenge questions, I think that you should cover in your worked examples. I mean, if you've got those super students who get through everything and always like an extension, I wouldn't put those in your examples because you want something to be able to stretch them. So you'd have your 3 things that you want them to learn that lesson, and then have some extension as well. So I wouldn't go through your extension questions because you want something to be able to challenge and apply these skills. But as long as they're based on the topics that I've already done, so as long as they were based on work example 1, 2, and 3, not, let's say, area.
And then I'm going to give Sam another go. You can answer on hopefully. Have you tried example by fading within your lessons to reduce cognitive overload, and how have the pupils found it?
I have, Sam, indeed, yes. I found that this was very, very productive. For those of you who don't know what fading is, if I had a question, I would give part of the answer and then gradually reduce it. So if I don't know if I can draw on here. No, sorry. So if I had this example where I had convert 0.648 to a fraction, I would give the students the answer and then just working out and gradually reduce the part that I want them to do each time. So you're fading the amount of work that they're doing that reduces their cognitive overload. I find that really, really works, especially with the lower retainers and students with SEN needs. They found that particularly useful because students with SEN needs actually have, especially dyslexia, their processing is different. Their brains actually process information differently. So that reduces the pressure that they have on their cognitive load, especially as SEN students have less amount that they can process at once. But I think that's a conversation for another day, Sam, because that is a brilliant way of doing it, but I don't want to confuse people.
And just before we go on to the next part, I just there was one question asking if there are going to be any more webinars scheduled. At the moment, we don't have anything scheduled, but hopefully Sarah's going to do another webinar on this kind of cognitive load series. We're also going to hopefully have one about technology and maths. There will be lots to come, and this is the perfect opportunity to talk about the blog that we have. Hopefully those of you that have signed up to this have already seen the blog as well, but that's also got lots of different topics on that. We will also be uploading a video, somebody asked me privately, this video of this session onto the blog as well for you to share with people. Have asked to share it with departments and things like that. And this network isn't just about us talking at you or sharing things with you. It's kind of meant to be a collaborative thing, which we want to build a network, make connections and share best practice. So the next section of this is actually